Now, what we just talked about were heating and cooling curves, and now I'm going to talk about phase diagrams, which are different and give you different pieces of information. So make sure that you can keep them separate. Heating and cooling curve tells you energy for heating and cooling. Phase diagram tells you specifically about phases at different temperatures and pressures. Now, these are just kind of some vocabulary terms here: critical temperature and critical pressure, which is not something we're going to focus on. We're going to look more at this. Is called a phase diagram, and it shows you, if you look at this, I've got solid, liquid, and gas. It shows you all of the temperatures and the pressures at which a substance would be solid, liquid, or gas. Okay, and at which temperatures you're going to melt or boil or sublimate or any of the different phase changes. So, sorry, let me turn it off. Okay, so it shows the temperature and pressure for solid, liquid, and gas of a substance. You'll notice I also have the critical points marked, which have to do with the temperature above which you can't actually turn something into a liquid, or the minimum pressure that you have to apply to liquefy something. Again, not something we're going to focus on. You can look more into if you want to. There's also what's called a triple point, which is a temperature and pressure where all three phases can exist at one time. And you can find all of that on this little chart. So it's always going to be on the top left is going to be solid, liquid in the middle, gas on the bottom right. Because if you think about it, things at very high temperatures are going to be gaseous. Things at very low temperatures and high pressures are going to be solid. So solid, liquid, gas. Okay. Now, after you label these, everything else is going to be different for different substances. This, I don't even know what substance this is for. But here's your triple point. This is a temperature and pressure, like if you follow your temperature and pressure at which we would be all three phases. If this is 1 atmosphere, I just decided to mark this 1 atmosphere. This point right here would be the normal melting point between solid and liquid, because anything along this line is the temperature at which we would go from a solid to a liquid, or vice versa, if we change the pressure. And over here is the boiling point, which would be the temperature or the normal boiling point if it's at 1 atmosphere to go from liquid to gas. So you can find normal melting points and boiling point, or not normal melting points and boiling points, using this called a phase diagram. Okay. So I've got 2 phase diagrams here to kind of show you. This is carbon dioxide versus water. One thing you might notice is that, first of all, this line between solid and liquid for carbon dioxide has a positive slope, whereas water between solid and liquid has a negative slope. And that is really because water's ice is less dense than its liquid, which is usually not the case, right? Ice floats. Usually solid things will sink in their liquid, but ice actually floats, and that's because the density is actually lower for ice. So you'll see this negative slope. The other thing you might notice is where your triple point is. So this triple point is at negative 56 degrees Celsius and 5.11 atmospheres, whereas for water, its triple point is actually very close to 0. To get these to actually exist at the same time is almost impossible for water, and at 4.58 torr, which is a very, very low pressure. So something very difficult to do, whereas these would definitely be doable in the lab. Reason that I use CO2 is because I want to talk about sublimation, or sublimation of dry ice. Actually happens in the atmosphere, right? You have a piece of dry ice, and that's because at 1 atmosphere, which is about where we are, dry ice, if you follow it over, this is where it would go from solid to gas. The line between solid and gas actually happens at negative 78.5. So it will sublime even when it's very, very, very cold outside. You will see dry ice turning into gas. So that's why it sublimates. Whereas if we tried to sublimate water, we would have to be, oh, that's 0 degrees Celsius. Sorry, thought it was something. 0 degrees Celsius. To sublimate water, you would have to be colder than 0, and you'd have to be at a very low pressure. Again, very difficult to get to 4.58 torr. But then you can find, again, everything else on these graphs, but they show you a lot of information, and they all look different for different substances. If I were you, I would try the next example by yourself and then check your answers. So go ahead and pause it. Now, I gave you this diagram. This is obviously not water because this has a positive slope, but what I would want you to do is label it solid, liquid, gas. Okay, this would be my triple point. And now let's do the question. So the normal boiling point, which means at 1 atmosphere, so we follow 1 atmosphere over to Boiling is when we go from liquid to gas. So I'd be like, okay, that happens about here. So about 200 degrees Celsius. Normal melting point would be pressure of 1 atmosphere, but going from solid to liquid. So here, about 150 or 145 or something like that degrees Celsius. CIS for the physical state of the substance, meaning solid, liquid, or gas, at 2 atmospheres, so 2 atmospheres, and 110 degrees. So I kind of plotted that for you. So all you have to do is follow that temperature and that pressure, and it's in the solid section, so it would be a solid. And if I ask the pressure and temperature that correspond with the triple point, I would be like, okay, here's a triple point, maybe about 110 degrees Celsius and about 0.75 atmosphere. So that's kind of how you would read it for a question like this.